So prior to now, we had just been graphing y equals a times the sine of bx, or y equals a times the cosine of bx, where that letter b changed the period of the function. It either stretched it out or shrunk it down. Well, now what we're going to do is we're going to add this constant value. It's no longer just the sine of b times x, it's b times x plus c. And this constant is going to displace or move the sine and cosine curves from their original starting point. Remember, sine starts at 0, 0 at the origin, and cosine tends to start high depending on the amplitude of the curve. So it starts high at the amplitude point, or low in case this amplitude value is negative. If you take your graphing calculator and graph y equals the sine of 3x and y equals the sine of 3x plus pi over 6, remember to be sure to be in the radian mode. And also, this window would be nice for your graphing calculator in graphing just these two. And when you do that, and I don't have my graphing calculator open with these two equations, but the sine of 3x with a maximum value of 3, 2 pi divided by 3 is about 2. So I'm thinking you get about that much of y equals the sine of 3x on your graphing calculator. But again, when you graph this next one and you have a plus sign right here, that curve will start right over here instead of right here, and it's just displaced, and it will follow the curve that you first typed in, the sine of 3x, but it will be shifted to the left. Now the big thing is this point right here where it's displaced to, the y value right there, the y value is 0, the output. So it means that the sine of whatever x is right there, 3 times that plus pi over 6, that the y value is 0, and all of that's got to be 0 because the sine of 0 is 0. So again, all of this has got to be equal to 0 because the sine of 0 is equal to 0 right there. So this curve, the second function, shifted to the left, and it shifted and crossed the x-axis at approximately 0.17, a negative 0.17. That's that spot right there. That's that x value. So I'm going to go here and show you why that's true. Since I want this to be equal to 0 so that the sine of 0 is equal to 0, I'll set this equal to 0. And so I'll subtract. To solve for x, I'll subtract pi over 6 from both sides of that statement, and I'll have 3x equals a negative pi over 6. And now, in order to solve for x, I'm going to divide both sides by 3. Well, when I take that pi over 6, the negative pi over 6, and divide it by 3, right here, which is 3 over 1, I'm going to multiply it by 1/3, and I get a negative pi over 18. And I'm going to get my calculator out right now and calculate pi divided by 18. And I get that, approximately 0.17. It's 0.1745 is where this curve is shifted to. So right here, this negative pi over 18 is where this sine curve got shifted to. Its displacement. Please notice it was 3x plus pi over 6. We ended up moving the pi over 6 to the left, or taking a negative pi over 6 and dividing by the coefficient of x, which was 3. The third function that's up above, I haven't had you graph that yet on the graphing calculator, but if you did, the first curve, y equals the sine of 3x, in black, will look something like this, and I think it will graph about to there. But this second curve, this third function that has a minus sign right here, it's going to be shifted to the right to that 0.17 amount. Oops. little bit off. So that spot right there is going to be a positive 0.1745. See this 0.1745? And that's because all of this has got to be equal to 0, so that the sine of 0 will be equal to 0, and that will give me that positive point. So if you're graphing the sine of 3x minus, then that curve will shift to the right to a positive, and that's because you add pi over 6 to both sides of the equal sign, and then you divide by 3. So we'll divide by 3 here. And so pi over 6 divided by 3 means to multiply by 1/3, and this curve is shifted by pi over 18 units. Finally, let's come up with a theory then. Again, please notice each time I took this, what we were taking the sine of, and I solved it for x, so it was 3x minus pi over 6, I ended up taking a positive pi over 6 and dividing by 3, or multiplying by 1/3. So let's come on over to the next page. If I have y equals a times the sine of bx plus c, and this c value or cosine, it doesn't matter, if the c value is greater than 0, or there's a positive sign right there, the curve shifts to the left. So if this is positive, I go left. If c is less than 0, so say this was a minus sign right here, if c is less than 0, then the curve would shift to the right. And the amount of the shift, which we call the displacement, we ended up taking the opposite of this c value, because remember, we set the bx plus c equal to 0, so we subtracted c from both sides, and then, and again, we're trying to solve for x. Then we divided both sides by the coefficient of x, and we can find out that that displacement is always going to be the opposite of c divided by b. And now, in summary, we have the 4 formulas that we will use as we graph the trig functions. First, I'd like you to always state the amplitude. Second, I'd like you to tell me that the period is 2 pi divided by whatever the value is in front of x, that's called b. And thirdly, that the displacement is found by taking the opposite of your c value and dividing it by your b value. I'm going to pause here and start a new segment, and when we do that, we're going to go into graphing some functions and look at the details.